a cos theta comma b sin theta, b minus a sin theta comma b cos theta, O origin and theta is a parameter, then locus of centroid of the triangle OAB. Locus of centroid of the triangle OAB. Now, O origin 0, 0. A coordinates given a cos theta comma b sin theta. The coordinates of the point B minus a sin theta comma b cos theta. Minus a sin theta comma b cos theta. Now, the vertices of a triangle OAB given. Require the locus of centroid of the triangle. Centroid of the triangle. If suppose consider Px comma y, Px comma y is centroid of the triangle OAB. Px comma y is centroid of the triangle OAB. Now, by using the points O0, 0, a cos theta comma b sin theta, b minus a sin theta comma b cos theta. Now, centroid of the triangle is x1 plus x2 plus x3 by 3. Now, 0 plus a cos theta minus a sin theta by 3, comma 0 plus b sin theta plus b cos theta by 3. Now, that equals to px comma y. Px comma y. Now, equating x coordinates, we get a into or a by 3 into cos theta minus sin theta equals to x. Similarly, y coordinates equate it, we get b by 3 into cos theta plus sin theta equals to y. A by 3 into cos theta minus sin theta equals to x. B by 3 into cos theta plus sin theta equals to y. From these two equations, eliminating theta, we get the required locus of the point. From these two equations, eliminating theta, we get the locus of the point. Now, x by a equals to cos theta minus sin theta by 3, y by b equals to cos theta plus sin theta by 3. Sin theta by 3. Now, these two equations by squaring and adding, we get x square by a square plus y square by b square equals to 2 by 9. X square by a square plus y square by b square equals to 2 by 9. Then the locus of the point Px comma y is an ellipse. Therefore, option is first option, x square by a square plus y square by b square equals to 2 by 9. Next problem. The locus of the point x equals to a plus b secant theta, comma y equals to b plus a tan theta. X equals to a plus b secant theta, y equals to b plus a tan theta. From these two equations, we can eliminating theta, we get the required locus. From first equation, x minus a equals to b secant theta. Similarly, from second equation, y minus b equals to a tan theta. From second equation, y minus b equals to a tan theta. Now, x minus a by b equals to secant theta. From first equation, x minus a by b equals to secant theta. Similarly, from second equation, y minus b by a equals to tan theta. From these two equations, eliminating theta, we get the required locus. Now, but you know, secant square theta minus tan square theta equals to 1. Secant square theta minus tan square theta equals to 1. Now, x minus a by b whole square minus y minus b by a whole square equals to 1. Now, the locus of given point is x minus a by b whole square minus y minus b by a whole square equals to 1. Then this equation represents a hyperbola. then option is third option. Third option is correct. The locus of the point represented by x equals to a by 2 into t plus 1 by t, y equals to a by 2 into t minus 1 by t, t minus 1 by t. Now, just eliminating t from two given equations, we get the required locus of the point. Now, both the equations square and subtract from first equation to second equation. X square minus y square equals to a square by 4 into t plus 1 by t whole square minus a square by 4 into t minus 1 by t whole square. Now, in right side a square by 4 is taken common, we get a square by 4 into t plus 1 by t whole square minus t minus 1 by t whole square. That equals to a square by 4 into, now a plus b whole square minus a minus b whole square, a plus b whole square minus a minus b whole square equals to 4ab. Now 4 into t into 1 by t. Now t get cancel, 4 also cancel. Therefore, the required locus is x square minus y square equals to a square. X square minus y square equals to a square. Therefore, second option is correct answer. X square minus y square equals to a square. A2, 5, B 4, minus 11, B 4, minus 11, and the locus of C is 9x plus 7y plus 4 equals to 0. The locus of C is 9x plus 7y plus 4 equals to 0. Then locus of centroid of the triangle ABC. The locus of centroid of the triangle ABC. Required the locus of centroid of the triangle ABC. Now given A2, 5, B coordinates 4, minus 11. The locus of C is 9x plus 7y plus 4 equals to 0. The locus of C nothing but the point C lies on the straight line 9x plus 7y plus 4 equals to 0. Now different positions of C on this line, we get different triangles. In that case, required the locus of centroid of the triangle ABC. The locus of centroid of the triangle ABC. Now consider the coordinates of the point C, some h, k. Coordinates of the point C, h, k, and centroid of the triangle ABC, px, y. Centroid of the triangle px, y. Consider required locus of the point px, y. Now, by using the points A2, 5, B4, minus 11, CH, k, then the centroid of the triangle ABC equals to 2 plus 4 plus h by 3, 5 minus 11 plus k by 3. But that equals to P, consider Px1 by 1. Now that equals to Px1 by 1. It is centroid of the triangle ABC. Centroid of the triangle ABC. Now by equating x coordinates, now we get 6 plus h by 3 equals to x1. Similarly, y coordinates equate minus 6 plus k by 3 equals to y1. Now from first equation we get the value of h equals to 3x1 minus 6. Similarly, k equals to 3y1 minus plus 6. Now the values of h and k are 3x1 minus 6, k equals to 3y1 plus 6. h equals to 3x1 minus 6, k equals to 3y1 plus 6. What the point C h comma k, C h comma k lies on the straight line 9x plus 7y plus 4 equals to 0. Then the values of h and k substituting in the equation of the line 9x plus 7y plus 4 equals to 0, it must be satisfied. Now 9 into 3x1 minus 6 plus 7 into 3y1 plus 6 plus 4 equals to 0. Now further simplify, 27x1 minus 54 plus 21y1 plus 42 plus 4 equals to 0. Now further simplifying, we get 27x1 plus 21y1 plus 46 minus 54 minus 8 equals to 0. Therefore, locus of x1 y1, locus of x1 y1 is 27x plus 21y minus 8 equals to 0. Now it is also a straight line. Now it is parallel to the given line, parallel to the given line. The locus of the point P is also a straight line. It is parallel to the given line. Then option is first option. Next, the base of a triangle lies on the line x equals to a, lies on the line x equals to a and is of length a, and is of length a units. The area of the triangle is a square. The area of the triangle is a square. The locus of vertex, the locus of vertex. If suppose consider PAB is a triangle and AB is base of the triangle, base of the triangle, and the equation of the base given x equals to a or x minus a equals to 0. Equation of AB equals to x minus a equals to 0. Now, and length of the base AB equals to a units. Length of the base equals to a units. And area of the triangle PAB, area of the triangle PAB equals to a square. Area of the triangle PAB equals to a square. Required the locus of the point P. Locus of the point P. Now consider P x1 y1. The locus of the point P required. Let P x1 y1 is vertex. Required locus of the vertex P x1 y1. Now the perpendicular distance from P x1 y1 to the straight line x minus a equals to 0 is mod of x1 minus a, mod of x1 minus a. Now the area of the triangle, the area of the triangle equals to half into base into height, half into base into height. Now that equals to half into your base equals to a, height of the triangle is mod of x1 minus a, mod of x1 minus a. But given area of the triangle is a square, area of the triangle equals to a square. Now both sides 1a cancel. Now cross multiplying, mod of x1 minus a equals to 2a. Remove modulus, x1 minus a equals to plus or minus 2a. x1 minus a equals to plus or minus 2a. Now if taking plus and minus signs, we get x1 minus a equals to x1 minus a equals to plus or minus 2a. If suppose taking plus sign, x1 minus a equals to 2a, or for implies x1 minus 3a equals to 0. Similarly, minus sign, x1 minus a equals to minus 2a, for implies x1 plus a equals to 0. Now the locus of the point P x1 y1 are two straight lines. These lines are parallel to the given line. Now combinedly the locus of the point is x plus a into x minus 3a equals to 0. The locus of third vertex is a pair of lines. These lines are parallel to the given line and equidistant from two lines. Therefore answer is 1. The graph represented by x equals to sin square t, y equals to 2 cos t, y equals to 2 cos t. The graph represented by x equals to sin square t, y equals to 2 cos t. Now from given two equations, by eliminating t, we get the equation. Now x equals to sin square t. Now x equals to sin square t equals to, in terms of cos, 1 minus cos square t. Now x equals to 1 minus, but from second equation cos t equals to y by 2. Substituting cos square t equals to y square by 4. Therefore, the further simplification, we get 4x or 4 into x minus 1 equals to minus y square, or y square equals to 4 into 1 minus x. Now this equation represents a parabola. But yet the parabola limits are up to 0 to infinite. But here the value of x lies between only 0 to 1, because x equals to sin square t, its minimum value is 0, maximum value is 1. Now x value only 0 to 1 and y equals to minus 2 to 2. Then the locus of the point or the graph of equation represents a portion of a parabola or part of a parabola. Then option is second option answer. If 2, 3 are the coordinates of a point P, in the new system, when origin shifted to minus 3, 7, then the original coordinates of P. Now, if suppose original coordinates of a point x, y, new system point capital X, capital Y, origin shifted to the point h, k, then the relation between small x, small y, capital X, capital Y and h, k is x equals to capital X plus h, y equals to capital Y plus k. X equals to capital X plus h, y equals to capital Y plus k. Here small x, small y is original point, capital X, capital Y new system point, h, k is origin shifted to that point. Now here 2, 3 is new system point, given 2, 3 is new system point. It is nothing but capital X, capital Y. Now origin translated to the point minus 3, 7. It is nothing but h, k. Minus 3, 7 is h, k. Now required original point small x, small y. Now x equals to capital X plus h. Now 2 minus 3, that equals to minus 1. Y equals to capital Y plus k. 3 plus 7, that equals to 10. Therefore, original point x, y equals to minus 1, 10. Original point x, y equals to minus 1, 10. Option is first option. If the axes are translated to the point minus 2, minus 3, then the equation x square plus 3y square plus 4x plus 18y plus 30 equals to 0. Now origin translated to the point minus 2, minus 3, x square plus 3y square plus 4x plus 18y plus 30 translated to the equation. Now here original equation given, origin shifted to the point minus 2, minus 3. Now required new system equation. Actually, if suppose f of x comma y, the given equation of the curve f of x comma y. Now, at place of, if suppose point h comma k, now new system equation is f of x plus h comma y plus k equals to 0. Means at place of x equals to x plus h, y equals to y plus k, substituting in the equation and simplifying, we get the required equation. Now, that is actually procedure. If suppose f of x comma y equals to ax square plus 2hxy plus by square plus 2gx plus 2fy plus c equals to 0. If suppose origin shifted to the point x1 y1, now in this equation first degree terms are missing, then the new equation, direct new equation is ax square plus 2hxy plus by square plus gx1 plus fi1 plus c equals to 0. Means in the new equation the coefficients of x square, xy and y square coefficients same as it is, no change. Only constant term will be changed. Now that is nothing but half of the coefficient of x into x1 or x coordinate of the given point, plus f into half of the coefficient of y into y coordinate of the given point plus c. Now in given equation coefficient of x square is 1, then the new system equation x square plus, there is no xy term, only 3y square plus half of the coefficient of x 2 into x1 minus 2 plus fy1 half of the coefficient of y 9 into y1 minus 3 plus c, constant is 30. Now further simplifying, we get x square plus 3y square minus 4 minus 27 minus 31 plus 30 equals to minus 1 taken right side, we get 1. Now x square plus 3y square equals to 1. X square plus 3y square equals 1. Then answer is second option. When the axes are translated to the point 5 comma minus 2, when the transformed equation of xy plus 2x minus 5y minus 11 equals to 0. Now origin translated to the point 5 comma minus 2. Now required transformed equation of xy plus 2x minus 5y minus 11 equals to 0. xy plus 2x minus 5y minus 11 equals to 0. In same previous problem also it can be do. Otherwise, in first two terms x take common, x into y plus 2. Next minus 5 into, write the same as it is, here coefficient of y into y plus 2 remaining constant. Now here minus 5 into 2 minus 10, but here minus 11. Now minus 1 equals to 0. Now complete equation is same as it is, x into y plus 2, in first two terms x common, we get y plus 2. Next y coefficient into same as this factor remaining constant equals to 0. Now x minus 5 into y plus 2 equals to 1, minus 1 taken right side 1. Now here the given point 5 comma minus 2. Now at place of x minus 5 equals to capital X, y plus 2 equals to capital Y, xy equals to 1. Now the required answer is xy equals to 1. Third option is correct. In order to make the first degree terms missing in the equation 2x square plus 7y square plus 8x minus 14y plus 15 equals to 0. Plus 15 equals to 0. The origin should be shifted to the point. Origin should be shifted to the point. Now, the given equation f of x comma y equals to 0. In this first degree terms are missing, require the new origin of the system. If suppose the equation actually formula f of x comma y equals to ax square plus 2hxy plus by square plus 2gx plus 2fi plus c equals to 0, then the new origin is hf minus bg by ab minus h square comma gh minus af by ab minus h square. Now, by using this formula, it is very lengthy calculation, but in MSET, the given equation consider s equals to 0. In shortcut method, the given equation consider s equals to 0. Now, the given equation differentiate partially with respect to x. Now, dou s by dou x differentiate partially with respect to x. With respect to x differentiating, y is treated as constant. Now, with respect to x, 2x square derivative 4x plus 8x derivative plus 8 equals to 0. Dou s by dou x equals to 0. Similarly, differentiate with respect to y. Dou s by dou y equals to, with respect to y differentiating, 14y minus 14 equals to 0. Now, just to solve these two equations, we get the values of x and y. That is the required new point. Now, by solving these two equations, x equals to minus 2 and y equals to 1, then origin shifted to the point minus 2 comma 1. Then option is fourth option is correct. The point to which origin shifted to in order to remove xy term in the equation 14x square minus 4xy plus 11y square minus 36x plus 48y plus 41 equals to 0. Similar problem, consider the given equation s equals to 0, differentiating partially with respect to x, dou s by dou x equals to 28x minus 4y minus 36 equals to 0. Similarly, differentiate with respect to y, dou s by dou y equals to minus 4x plus 22y plus 48 equals to 0. By solving these two equations, we get the required point. Solving two equations, we get the required point. That is, just solve these two equations, we get 1 comma minus 2. Solving these two equations, the point is 1 comma minus 2. Option, first option. Next. If the distance between two given points is 2 units and the points are transformed to shifting the origin to 2 comma 2, then the distance between the points in their new position. If suppose A and B are two fixed points, if suppose x axis and y axis with respect to original axis A and B, now the distance between 2 points equals to 2 units. The distance between A and B equals to 2 units given. Now, if suppose origin shifted to any point, any other point. Now, with respect to the new axis, the position of the points changes, but the distance between 2 points no change. Then Answer is 2 units. Then first option is correct. Next. The transformed equation of x square plus 2 root 3 x5 minus y square minus 8 equals to 0 when the axes are rotated through an angle pi by 6. Through an angle pi by 6. Now, in rotation of axis, if suppose x comma y is original point, capital X comma capital Y is new system point, and theta origin, the axis are rotated an angle theta. Now the relation between x small x comma small y, capital X comma capital Y and theta is x equals to x cos theta minus y sin theta, y equals to y cos theta plus x sin theta. But here theta equals to given pi by 6. Now we get the value of small x in terms of capital X and capital Y. Now cos pi by 6 root 3 by 2. Now x into root 3 by 2 minus y into sin 30 1 by 2 or x root 3 minus y by 2. Similarly, y equals to y cos theta plus x sin theta. Y cos theta plus x sin theta. Now that equals to x into sin theta sin 30 1 by 2 x by 2 plus y into cos theta, but cos 30 degrees equals to root 3 by 2 root 3 y by 2. Now at place of x equals to x root 3 minus y by 2, y equals to x plus root 3 y by 2. Substituting in the equation and simplify, we get x root 3 minus y by 2 whole square plus 2 root 3 into x root 3 minus y by 2 into x plus root 3 y by 2 minus x plus root 3 y by 2 whole square minus 8 equals to 0. Now further simplify, we get x square minus y square equals to 4. X square minus y square equals to 4. Then option is second option, x square minus y square equals to 4. Next. If the axes are rotated through an angle 180 degrees, axes are rotated through an angle 180 degrees, the equation 2x minus 3y plus 4 equals to 0 becomes 2. 2x minus 3y plus 4 equals to 0 becomes 2. Now here theta equals to given 180 degrees. Now x equals to x cos theta minus y sin theta, y equals to x sin theta plus y cos theta. Now theta equals to 180 degrees. Theta equals to 180 substitute, we get small x equals to cos 180 minus 1 sin 180 0. Now x equals to minus x. Similarly, y equals to minus y. Y equals to minus y. Now at place of x equals to minus x, y equals to minus y, replace, we get 2 into minus x minus 3 into minus y plus 4 equals 0. In complete equation, minus is taken common, we get 2x minus 3y minus 4 equals 0. Now it is the required transformed equation of the line 2x minus 3y minus 4 equals 0. Then first option is correct. If the equation 4x square plus 2 root 3 xy plus 2y square minus 1 plus 2y square minus 1 equals to 0 becomes to 5x square plus y square equals to 1. 5x square plus y square equals to 1. When the axes are rotated through an angle theta, then theta equals to Now, in the new equation 5x square plus y square equals 1. Now, in this equation there is no x into y term, x into y term. Now, in the transformed equation the xy term, x into y term is missing, then axes are rotated through an angle theta equals to half tan inverse 2h by a minus b, half tan inverse 2h by a minus b, theta equals to half tan inverse 2h by a minus b. Now, here a equals to, in given equation a nothing but coefficient of x square, that is 4, 2h equals to coefficient of xy 2 root 3, b equals to coefficient of y square 2. Now, substituting in the formula we get theta equals to half into tan inverse 2 root 3 by 4 minus 2, or that equals to half into tan inverse root 3, but tan inverse root 3 is nothing but pi by 3, half into pi by 3, pi by 6, pi by 6 or 30 degrees. It is nothing but pi by 6 or 30 degrees. Option is second option. If 3 comma minus 4, if 3 comma minus 4 is the point which origin shifted and the transformed equation x square plus y square equals to 4, x square plus y square equals to 4, then original equation. Now, given transformed equation x square plus y square equals to 4, origin shifted to the point h comma k, equals to 3 comma minus 4. New system equation x square plus y square equals to 4, but required original equation. Now, you know x equals to capital X plus h, y equals to small y equals to capital Y plus k. Therefore, capital X equals to x minus h, capital Y equals to y minus k. Then x equals to x minus 3, capital Y equals to y minus of minus plus 4. Now, in the given equation of the curve, substitute at place of x equals to x minus 3 and y equals to y plus 4. Now, x minus 3 whole square plus y plus 4 whole square equals to 4. Now, further simplifying, we get x square plus y square minus 6x plus 8y plus 9 plus 16, 25 minus 4 plus 21 equals to 0. Now, it is the required original equation of the curve x square plus y square minus 6x plus 8y plus 21 equals to 0. Then answer is third option. Next, if area of the triangle is 5 square units, then the area of the triangle when the origin is shifted to 1 comma 2. Now, area of the triangle is 5 square units. The area of the triangle is 5 square units given. With respect to original axis, x axis and y axis, the area of the triangle is 5 square units. If suppose origin translated to 1 comma 2, origin shifted to the point 1 comma 2, new axis x dash and y dash, original axis x axis, y axis. Now, with respect to the original axis, with respect to the new axis, the area of the triangle no change. Means if axes are translated to any point, otherwise the axes are rotated through any angle, the area of the triangle no change, but vertices of the triangle changes. With respect to the new system. Then answer is 4. When the axes are rotated through an angle 135 degrees, axes are rotated through an angle 130 degrees, initial coordinates of 4 comma minus 3 initial coordinates of 4 comma minus 3 are. Now here theta equals to given 135 degrees, new coordinates capital X comma capital Y given, required small x comma small y. Initial coordinates small x comma small y required. Now x equals to x cos theta minus y sin theta, y equals to y cos theta plus x sin theta. Now given theta equals to 135 degrees, new point 4 comma minus 3, required original point small x comma small y. Now that equals to, here capital X equals to 4 into cos 135 degrees. Cos 135 equals to minus 1 by root 2 minus y. Y equals to, y coordinate equals to minus 3, minus of minus plus 3 into sin 135 1 by root 2. Now that equals to minus 4 by root 2 comma plus 3 by root 2. That equals to, we get minus 1 by root 2. The value of x is minus 1 by root 2. Similarly, y equals to y cos theta plus x sin theta. Now here y equals to minus 3 into cos 135 degrees minus 1 by root 2 plus x into sin theta. Here x is nothing but 4 into sin 135 1 by root 2. Now minus into minus plus 3 by root 2 plus 4 by root 2, that equals to 7 by root 2. Therefore, the required original point x comma y equals to minus 1 by root 2 comma 7 by root 2. Minus 1 by root 2 comma 7 by root 2. Then fourth option is correct. Next. The transformed equation of 3x square plus 3y square plus 2xy equals to 2. When the coordinate axes are rotated through an angle theta equals to 45 degrees. Theta equals to 45 degrees. Now given original equation, required transformed equation when theta equals to 45 degrees. Now x equals to x cos theta minus y sin theta, y equals to y cos theta plus x sin theta. Now theta equals to 45 degrees, we get substitute theta value cos 45 1 by root 2, sin 45 also 1 by root 2. Now we get x equals to x minus y by root 2, y equals to x plus y by root 2. Now in given equation at place of small x equals to x minus y by root 2, y equals to x plus y by root 2, substitute and simplify, we get 3 into x minus y by root 2 whole square plus 3 into x plus y by root 2 whole square plus 2 into x minus y by root 2 into x plus y by root 2 equals to 2. Now further simplification, we get 2x square plus y square equals to 1. Therefore, second option is correct. Second option is correct. The angle of rotation when the axis in order to eliminate xy term in the equation x square plus 2 root 3 xy minus y square equals to 2a square. 2a square is. Now in the given equation xy term is removing, axes are rotated through an angle theta equals to half tan inverse 2h by a minus b. Half tan inverse 2h by a minus b. Here a equals to the coefficient of x square 1, 2h equals to 2 root 3, b equals to minus 1. Then theta equals to half tan inverse 2 root 3 by 1 minus of minus plus 1, or that equals to half into tan inverse root 3. Half into tan inverse root 3. Now tan inverse root 3 equals to pi by 3. Now half into pi by 3, that equals to pi by 6. Now the required angle is 5 by 6, then option is 1.